Hello, hello. Quick review of what we went over. This is chapter 7, section 2. We can handle integrals of sine and cosine where the powers here are things like 1, 2, 3, 4, etc. and some reciprocals. 1 over sine to the first, 1 over sine to the second. That's a lot to know. Now, it's a few different tricks that get employed, but the big idea is these are doable integrals. That family of sine to the first, sine to the second, sine to the third, sine to the fourth, etc., and then 1 over sine squared. All doable. Same thing with the cosines. So here's a quick example. If I have sine cubed times cosine cubed, the move is to set aside 1 cosine x. Just set it aside and don't lose it. Change the other cosine squared into 1 minus sine squared, because now it's all powers of sine times a single cosine. So the final answer is actually pretty easy, because you have sine to the third x sine to the third x times cosine x. The derivative of sine is cosine. So you have chain rule. Sine to the fourth over 4. Same thing with this sine to the third times sine to the second. That's sine to the fifth. So we get this sine to the 6 over 6. The minus sign is because of that subtraction right there. And don't forget the plus c. So you've got this problem done. It looks like a hard problem, but it's doable. The only weird one is this one that's way up here. We have the integral of 1 over sine x. That's a toughie. You change that to cosecant and multiply top and bottom by this version of 1. And then you finally get this answer over here. Tough answer. The main idea is that this integral is also doable. You don't have to have this memorized. That's why it says FYI. And then we're using these two formulas up here a lot. These two formulas. Those are going to get used a lot throughout the semester. I will print those on tests because it's hard to remember who gets the plus sign and who gets the minus. But we in class today, we did a bunch of examples of families of trig integrals. So that's what it was. The summary is, one more time, because I want to emphasize this. We can handle sines and cosines to various powers, and then we can handle these things. In these structures.